Okay, so let's go over the warm-up. So looking at this first problem, so there was a couple things I'm looking for on this problem. One is I gave it to you out of context, so you needed to determine what type of sequence are you looking at, right? So because we don't know at this point, but if you notice, if you take 300 multiply it by 1/2, you get 150. If you take 150 multiply it by 1/2, you get 75. If you take 75 multiply it by 1/2, you get 37.5. So this is geometric, where the common ratio is 1/2. So I'm just going to put down my common ratio here. So my common ratio is 1/2, and my first term in this case is 300. In regards to that, is there anyone who's not sure how I figured out it was geometric? Okay, from here, in order to write the rule, all you need is a first term, and you need a common ratio. So we've got both of those. So I think you'd agree. Our geometric sequence is going to be the first term, which is 300, times the common ratio, which is 1/2, raised to the power of n minus 1. Then if we want to find a specific term, which we do, we want to find the 8th term, we're just going to plug in our values. So our 8th term, in this case, is 300 times 1/2 to the 8 minus, handwriting is devolving, 8 minus 1. So we get 300 raised to the 1/2 times 7, which I get you can either have this as a decimal or a fraction. Mine returned it as a fraction, so I'm going to keep it like that. 75/32. In regards to number 1, do you have any questions? No? Before I move it down, does anybody need a little more time to get anything down? Okay. Again, I just want to kind of point out here, there was a couple things that I'm looking for. One is, could you recognize what type of sequence it was? Right? I didn't tell you what it was, you had to recognize that.
How do you recognize?
So in this case, right, if it's one of our specific sequences, if it's arithmetic, I'll be adding the same value over and over and over again, which I wasn't.
Oh, yeah.
Yep. Or if it's geometric, I'll be multiplying by the same ratio. Okay, let's continue. Let's look at the second one. Okay, for this one, similar-ish problem, but now it's a series, and we're asked to write this series in summation notation. So the first thing I'm going to do is just write a formula for the sequence, and then I'll kind of fit it into my summation. So in this case, let's notice what's going on here. We are adding 7 each time. And since we are adding 7 each time, this is going to be arithmetic. So in order to write an arithmetic sequence, we take our first term. Actually, let's go through and do some identification here. So we take our first term, which is 15. We take our common difference, which is that value we're adding each time, 7. And so now we're going to plug it into this. So I get 15 plus n minus 1 times d, which is 7. I'm going to clean this up. So it looks like I get this. So it looks like I get 8 plus 7n. In regards to the sequence, again, there's a lot more that we have to do here. Is there any questions about the sequence?
So if it's arithmetic, you're always going to use like that formula, and then if it's geometric, you're
Yep.
going to use
Yep, so there's two different formulas for both of this arithmetic sequence and geometric. Okay, from here, let's put this in summation notation. I'm going to go to i's like we usually did. So I'm going to take these n's here and I'm going to change them to i's just because I like that a little bit better. So we are going to start at I equals 1. Our formula is 8 plus 7i. And then we need to know where to end. So I don't currently know where this ends. What is the upper bound? So remember, the way we do that is we take this number right here and we're going to plug it into a to the n. So in other words, I'm going to kind of do this off to the right so I can see it. So we get 148 equals 8 plus 7n. Was it 148? Yep, it was 148. So 140 equals 7n. So it looks like n equals 20. So in this case, our upper bound is 20. Questions?
Do you always have to like write it in the thing on the top, the like M thing? Because what does it help you with?
One more time. I didn't quite understand the question.
Like, do you always have to write the sideways M thing?
Yes, for a summation, for a series, if I'm asking you to put, so the question was, do you have to do the summation notation? This is your summation notation, so yes, because what you're saying is,
So that's the like final formula.
right, because this is a series, and this thing tells us that this is a series, and we're plugging in the values in order to add this up. So absolutely, you got to put that, when it's a series like this, where we're going to be adding these all up together, you have to put in that notation. That's our summation notation. So especially when I'm saying write in summation notation, that's specifically what I'm looking for. Yes.
Will it always be I equals 1 at the bottom?
Yes, I want you guys, so the question is it always gonna be I equals 1? If you're writing the sequence, our series, I'm asking to start at 1. You can be given, in the book, they could be asking you to do things. So we've seen it where sometimes I equals 4, up to 7 or something like that. That's a little bit different. But when we are writing ours, we're starting at 1.
Does it matter if like we don't change the like because it was 8 plus 7n, but then we changed it to 8 plus 7i? Is that like the same?
So you're asking if instead of using i's here, we used n's, or vice versa?
Yeah.
Yeah, it doesn't matter. So whatever the variable is, what you want to do is you want to make sure this variable right here agrees with that whatever variable is right there. Other than that, it doesn't actually matter. If you notice, the book actually even used n's too. I don't tend to like to, of the letters I like to use, I don't like to use n, just because it tends to represent this and it's a little confusing. But it technically doesn't matter as long as this matches this. You're good to go. Any other questions? Okay, I'm going to stop it.